Hello, Greg. Hello, Mark.
Yay! It's the Ceph Performance Weekly. I have no audio.
Morning, folks.
Morning.
Mark, I'm not hearing audio from you.
Right, yep.
Yep, that
Yay!
was because my microphone was off. Oh well. I assume you can hear me now?
Much better.
Very good.
My lip reading isn't very good, so it's better.
All right, so let's see. We can get this thing started. Um, so we've got 2 weeks worth of PRs, but actually there's nothing brand new here that hasn't been closed out yet. So a couple of different things merged. Oh, good. Sage is here. Hey, Sage. I don't hear you. You have the same problem I did.
There. Is that better?
Very good.
Right. Okay. Are we starting? See, I'm just looking at
Yes,
this
we
list.
are.
I've been following these. A bunch of stuff merged. That's good. The PG stats one's closed, which is good. It made me nervous, although it could have worked. More stuff. Um, I don't see the VLA pull request that you mentioned, Jesse. Is that here?
It, I must have missed it.
Anyway, okay.
Let's get this in. I will.
Add to the list.
Here.
Oy, oy, oy. Lots of changes. All right.
Here we go.
What else? Let's see. The hypercombined bufferless stuff. I started to look at it, but it made my brain hurt. Kifu's going to review it. Be more effective than I am. And perf counters to threaded storage. That sounds good. Looked at that one. EC stripe cache. I thought there was an EC stripe cache. Maybe it's only for in-flight operations though, and not for And a distributed data cache. Is this something out of MOC?
Yes.
Okay, cool. Bunch of cleanup to be done. Rebasing. Okay. Anything else worth mentioning here?
Sage, I wanted to ask you and probably Radek. Radek and I were talking about this before, but with the hypercombined buffer lists, one of the things I keep wondering, well, I've been wondering lately, I guess, is what's the cutoff between just like doing a mem copy and saying screw all this complexity versus actually trying to keep up with the having
Mm-hmm.
pointers to things all over the place and
Yep. I think it's the size of the buffer.
Yes, that's
Yeah.
the main problem. I was trying to figure out whether the buffer sharing behavior of buffer list is where it's actually used. I can find that. Well, I was started from just deprecating the copy constructor of buffer list, and I saw hundreds of usage.
what worries me is that Radek, you are brilliant and you have been studying this for like a month now. And Sage
Yeah.
just said that his brain hurts when he looks at it. And that's a problem, right? Like if
And I'm
Sage's
not
brain
surprised.
hurts when he looks at it,
It's
that
terribly
means that the
complex.
rest of us are gonna be in really
Yep,
bad shape if we ever go and try to fix it.
We are trying to fight our the performance issue in buffer list by adding even more complexity to it.
Yep, and I'm starting to wonder, would we be better off just mem copying and just doing something super
Yeah.
dumb and simple, and then selectively maybe.
I think the way to approach this is to be careful with the investment of complexity in buffer list. Like show good gains before we make it too much harder and simplify the API whenever possible, which we've been doing a little bit of both of. But then with Crimson, don't use buffer lists at all. Try to start with the primitives and then go from there. I think that's the way to, because I think it's going to be a real challenge. There's going to be a ton of code rework if we just start to like rip out buffer list from the current code base.
I'm afraid that even in Crimson, it will be a huge pain. In Crimson, we wanted to exchange maybe not more than a few percent of code base. Basically, only those parts that are essential for performance.
Mm-hmm.
Rewriting the machinery for taking care of rebalance of the cluster health. Well, it will be rewriting it from scratch without buffer list might be a pain.
Yeah, right. But so I think that the idea with Crimson is to focus on the IO path, and so reads and writes really would be written in terms of C star buffers or whatever they're called, and not use those buffer lists for data. I think if we do that, then we avoid sort of the hot usages. And then that's my thinking at least.
Well,
I mean, I wouldn't touch any of the peering stuff. Like that's where a lot of the complexity and correctness comes in, and it's not.
But still, even if somebody uses std string, nowadays std string,
Mm-hmm.
it has sharing behavior inside.
Yeah. Yep.
What do you mean by sharing behavior?
It does like reference counting and sharing of the buffer or whatever.
Sorry.
In stud string in particular, what do you mean by sharing behavior?
Are you there, Radek?
I don't think any standard libraries are doing the copy on write stuff anymore, right?
They used to, didn't they?
Well,
Maybe
C++
they run it.
17, some of that has changed, but I need to look at stud string in particular to see if anything in the actual library has changed.
Yeah, it's a bit of a tangent. I think it doesn't actually matter in this case.
So with
Sorry,
respect to
guys.
C star and buffer list, I had assumed that we were going to stick with buffer list there, which isn't great, but mainly just for compatibility with our existing messages, just for encode
Yeah,
decode of that stuff.
I mean, I
But
think
if
bufferless is going to be there. Certainly, we can't get rid of it, but I would try to like when we write the message primitives or like the messenger stuff, like try to do that in terms of buffers where possible, and on the I/O path, for example, try to do that in terms of buffers and skip the bufferless part wherever we can.
so if the Crimson OSD only cares about the one MOSD app message, then we could write the encode decode in terms of
Right.
non-buffer list. I think that would avoid most of it.
Yeah, for example, right, exactly.
Sorry, guys. I'm having issues with my network connectivity. I've lost some parts of the conversation. Last part I heard this was about the encode and decode without buffer list. Is it a viable option actually?
I suspect so. I'm not. I'm not really sure. I admit I'm not really following the Crimson stuff right now. I'm not the person to talk to about it. But my general sense, and again, I defer to the people who are actually doing the work here. But my general sense is that where possible, we should try to use the C star buffer primitives,
Okay.
and only use bufferless where we need to for compatibility with all the other code.
Okay, got it.
Yeah, so one of the choices I had made with the C star messenger was to redo the messenger and connection types, but use the existing message encode decode
Hmm.
related to buffer list.
Yeah.
So if we want to change that, then we basically have to duplicate the encode decode for the messages that we want to support.
Or make a set of wrappers like C star encode and C star decode, and those fall back to some stuff that does the bufferless. But if you specialize it, you can write a native encoder, maybe something like that. We can selectively optimize the handful of messages that we think matter.
I wonder, I mean, if we actually went through and audited the code that uses buffer list, can we do that at that level rather than trying to make something kind of generic that does a fallback or can selectively optimize? I guess I feels like some of the complexity right now is because we use buffer list for everything.
Yeah. Yeah, it's a lot harder to like if we try to change everything to be in terms of buffer, or try to change specific things to be in terms of buffer pointers instead of buffer lists, for example, or something analogous. I think that's harder because everything right now is written in terms of buffer list, and it's all sort of generic.
And this is true even for cases where the sharing behavior is, I guess, the main point of buffer list is more a problem than benefit. If we are operating on small chunks, like typically, like most of the things we store in OMAP, I guess. Well, there is a threshold under which doing the mem copy is more performant way than sharing the buffers, because sharing means atomical operations, means the whole burden of allocating extra buffer pointers, means also fragmenting underscore buffers container of buffer list.
Well,
So
yeah, and
I was.
yeah.
I
It
was
has also
thinking
memory
about,
memory fence instructions.
of course, that's the issue with Atomics on x86. They are doing full memory sync.
I have a feeling that the other problem with OMAP that might be a lower hanging fruit is just that it's getting decoded into a map and then re-encoded and then decoded into a map. And I think we can probably bypass a lot of that work by fiddling with the interfaces. So that when something comes in over the wire, it's all encoded in a sequential buffer. We should be able to pass that straight down to the object store layer and then copy it into the RocksDB buffer, hopefully, without allocating a red-black tree, packing it.
Do we even need to copy it into RocksDB? Don't they give you facilities for actually getting, like, if you already have a sequential now, really?
Yeah, right. Yeah, that's one of the challenges. Yeah.
Okay.
The pain is because of right batch of RocksDB. It's implemented on top of std string.
I think that copy is like the least of our concerns. It's the you know, 50 OMAP keys on 50 allocations of whatever's. Yeah.
Yeah.
Like hundreds of bits of memory that you're fiddling with.
Well, it doesn't make one not interesting. I think the general buffer list improvements are important in their own right.
Yeah.
I had to change that tried to change how the OMAP buffers were and to use flat map so that it would, because it's constructed in sorted order.
Yeah.
But I've had a few problems with it and didn't pursue it.
Yeah, I thought we started to do some of this, but I would actually try to avoid unpacking it at all. Like maybe have a function that will just like walk the structure, the encoded structure, to make sure it's valid. To do a validity check, but not actually unpack it at all, and then pass that.
That may be appropriate for a few cases, but it's not going to solve all of them. There's a bunch of stuff going out in the other direction where we construct maps, where we're filtering them, we're merging them, doing intersection. Yeah. So it's not going to be a panacea for OMAP.
No, it would at least help the right. Yeah, we have. Yeah, I think the reads and write. Figure out what the common paths are, right? Reads and writes, get range, whatever it is.
Yeah, I know. I certainly don't object to anything. We can micro benchmark and we can actually measure the improvement of. But I certainly don't want to. I don't want to say we're not. Let's not work on buffer lists, which is highly generalized and very important.
No, I agree.
Because of OMAP.
Yeah, totally agree. Anyway, I guess coming back to where we started, I think my general feeling is yes, the hyperconfined buffer list is complicated, but I have a feeling it's going to be worth it. But we should also keep in mind that when we're doing the Crimson stuff, we should try to avoid buffer lists wherever possible. And only use it when we need to drag in all the other existing code.
That's appealing.
Okay, I'll raise a topic on the Ceph devel list about that in terms of the ongoing messenger work, so that we can hopefully get the interface changes in before Kipu starts wiring up an OSD.
Yeah, that sounds good. Okay. Cool. All right. You want to talk about the LVM NVMe thing, Mark?
Yeah, sure. So we had a user from the UK who was running on a bunch of HPC gear, and they were seeing this huge dramatic drop in performance with stuff deployed on LVM devices. And we went through, did a whole bunch of analysis, and we don't have it 100% nailed down yet, but it's looking very, very, very similar to another bug that was discovered with XFS on top of LVM devices with Intel NVMe drives, where when IOs cross certain boundaries, it results in this performance degradation. And it kind of has to do with the way that these NVMe devices have internal RAIDs and distribute IO to things internally, to the flash cells internally. So the gist of it is that I think it's only on an older version of the kernel. They've done some changes. There's actually been a lot of changes in the DM layer since the 3.x series. 4.x looks a lot different, and then there's a patch for 3.10 that is different than what's in 4, but I linked to it in the Etherpad here. The only reason I wanted to bring it up here is because now that folks are starting to use Ceph volume for deployment, they potentially could get bitten by this if they're using certain NVMe drives and also are on older kernels. So if you see a huge sequential read performance drop, this would be probably the first thing you should look at, is my guess, especially if you're using LVM or Ceph volume for deployment. So I guess it's more of a public service announcement than anything, but that's what to look for. So that's it.
All right. Do we have anything else we want to talk about today?
Maybe just one more word about on the matter of buffer list, especially in environments without sharing, like possibly C-star. We know that a lot of costs of applying buffer list comes from its sharing behavior. I mean, ref counting, memory fencing, all that crazy stuff.
Yep.
We can do nothing with that if somebody, for instance, mixes C-string appends with buffer list appends, with buffer pointers appends, etc. I don't see any possibility to avoid inflation of underscore buffers. I don't see any way to avoid atomical operations. But if somebody uses only buffer list without imposing the sharing behavior, well, we can basically eradicate all atomics. I made a pull request at the moment. I posted a link to it. At the moment, it's work in progress. It's built on top of the hypercombine thing, but actually they are two interesting changes from the sharing standpoint of view. One is on creation of first buffer pointer that points to a freshly created buffer row. At the moment, if you create a buffer row and create the pointer owning a given row instance, even in such condition, you have atomical operation. You are atomically increasing nref member of row from 0 to 1 using atomic. Bad idea. But just with some kind of extra bit of information conveyed type system, we can avoid that. Second thing is decreasing, is taking out an instance of buffer pointer when it's only where we have only one user of particular buffer row. We can avoid atomical operation there, I think. So if you have only let's say you have an instance of buffer list that has one buffer pointer pointing to one buffer row. If so, you wouldn't see any atomical traffic both on creation and destruction. That's the main idea of the pull request.
That's extremely common, so that seems very useful.
Yep. Yeah, it sounds great.
But still, if somebody would mix string taking variant of append with the buffer pointer taking variant, well, it's over.
Have you thought of ways to audit or make the code or maybe self-auditing for that case? That would be intriguing. You want to identify the places where that's happening and remove them.
Emitting a warning in such situation? I'm not sure I understood you correctly.
Well, something I'm not specifying, but I mean basically that could probably be eliminated in most cases, if not all of them. It's just an idiomatic error, right? In a new world of your design.
You are thinking about a way to find such bad use scenarios at compile time.
Or whatever, or perhaps if they, for example, imagine you sanitize everything and it's perfect at time t, you just want to stop it from reemerging.
Yeah,
I see.
In the C-star world, it seems to me like you'd almost want, right, to be copying your memory into whatever local memory you have for the shard as operating on a single core, and then at that point you've got already some pre-allocated memory that you've written into, and you're never doing any kind of like crazy stuff with it, right? It's just you're operating on it locally. Is that
right? That's basically the kind of buffer you get from the messenger, right? Just allocated on that core, and as long as you don't move it, you don't need to ref count.
I mean, that seems like that's where we should be trying to like move toward. Like that's
and like having an explicit handoff when the message is owned by the messenger, then it's owned by the OSD, and then given back to the messenger or whatever. If that handoff is explicit, right now, like it's a message ref. Who knows where the references are in the system? But if we have a more read ownership change, then it can be a lot more.
so how does the work that we're doing now get us from where we are to there? Does it?
No, I think it doesn't. I think that's why the Crimson stuff is working a little bit more from the ground up. Instead of like trying to modify async messenger to work with C star, it's just writing a fresh implementation using different primitives.
I wonder if even with our current code, if we should just try to, even if it's not a win, if we should start moving toward that, just so that we start like.
Yeah.
I personally think about C-star just like a quite small rewrite of some critical parts of the project, like messenger, like read write, maybe OMA path of OSD, but definitely not as a rewrite of our critical but rarely used things like rebalancing.
Peering. Right.
So I bet we'll need our things to coexist for years, to be honest.
Yeah,
that's right.
I suspect what's going to happen is they're going to implement a minimal IO path that's like mostly from scratch, and that's not going to include anything from like primary log PG, replicated backend or whatever. Like it's going to be pretty minimal and fresh. and that'll give us an idea of what the new structure should look like. And then there's going to be a painful process of either refactoring current ost.cc and primary log PG code, or re-implementing it in sort of the new style. But all of the stuff that's in like pg.c, all the stuff around peering and PG logs and all that stuff is like not going to need to change because it's not in the hot path. All the peering logic isn't, and it's right. It doesn't deal with any of like inter-thread communication or whatever. It's all under the global PG lock. So.
And it's stable, I think.
And it's stable, right?
There
Yeah,
was
we have
a
like
lot of effort.
a long investment in making
Yes.
that exactly right. But I think that the sort of the core flow through the OSD for IO and also for recovery is gonna like that data path part is gonna need to be rewritten. And hopefully simplified and streamlined and whatever in the process. And that's going to be hard. But I think once we have a minimal implementation, we can sort of plot a course to doing that. So there's going to be a lot of code that needs to be moved around, like we need to figure out how to factor all the stuff that's not the IO path, all the peering, PG log, all that stuff, so that it can be reused.
Related to that, Sage, I still think it would be a really good idea to just implement some kind of PG that doesn't do log-based recovery at all, just does nothing, right?
Yeah.
Just to see, can we plug something like that in and then kind of re-abstract it so that we have primary log PG as one kind of thing that can implement it.
Exactly. There's just a lot of code reorganization and refactoring just to clean up that interface to make that possible. And we've made like some initial steps in that direction, but it always gets sort of put on the sideline because of more immediate demands. But yeah, I totally agree.
Radek, we were talking the other day about like doing something like experiments with memcopy.
Yes.
The
idea.
Go ahead. You had an idea.
Well, at the moment, it's just an observation that we are using buffer list. I mean, especially the append method of buffer list, taking buffer list or buffer pointer and doing the shallow copy. By shallow copy, I mean just doing the ref counting on appropriate buffer row instead of running with memcopy. Well, I bet there is a threshold under which the memcopy will be much more performant. And still, we can. I'm pretty sure we just cannot enforce deep copy behavior on each append on each buffer list append. But maybe we could try to add slightly more complexity, basically an if to perform memcopy for those buffer lists that have which have small content inside. We have at the moment quite similar logic inside of contiguous appender. It has a constructor. The constructor of contiguous appender has extra parameter called deep. By default, it's false, but in Bluestar for encoding extent map, we are enforcing our contiguous appender to actually do deep copy of each buffer pointer or buffer list that is passed to it. Maybe we could try to adapt similar behavior to to both buffer pointer and buffer list taking variants of buffer list append. Just try to go with memcopy under some predefined size, like 128 bytes or something like that. Still, it would impose extra some extra logic just to detect, just to check whether it's worth doing memcopy or not. So it would impose some little extra cost.
Radek, my selfish hope is that if it turns out to be really useful, then maybe it means that we can do things that are that we could do it more explicitly rather than doing like a runtime check. Have things that aren't gonna, that aren't going to use buffer list in a way that very often that would be large. If we can then just explicitly use something that does memcopy rather than doing the check on it. Does that make sense?
Sorry, could you repeat, please?
If this works well, like if we see that oftentimes it's better to do the memcopy, I wonder then if then in the future we can make it so that instead of doing a runtime check on the size, we just kind of almost.
I see.
Yeah.
Okay, you are thinking about switching the append, the main variant of append for appending buffer list to buffer list to do memcopy and try to profile the code for as many scenarios as possible to detect those cases where we would copy jumbos and switch them to something like explicit shallow append of buffer list.
Something along those lines. Maybe the runtime check doesn't matter though. I don't know, but just
What?
I have no idea.
Can I just ask what I mean? What is the alternative? And the shallow copy is what set of operations appending a new buffer pointer?
Yes, that's the.
I mean, and why is it faster to do a mem copy?
Well,
two reasons.
if you would append a buffer pointer with 4 megs inside, with a content of single RBD segment inside, well, I guess that taking the cost of couple of extra atomics is nowhere close to copy of 4 megs.
I mean, this honestly, though, feels a little bit off track. I mean, if we want to avoid atomic operations, we should avoid atomic operations because these are cases where in a classical IO path, you want to use IOVX for things that are not tiny, but for tiny operations, the CPU is fast. But for things that are several K, this is efficient. And if we just created the problem with atomics, then memcopy isn't the way around it. Because that's expensive too, and it has impact on cache line and.
Not entirely. You can use, for instance, non-temporal memcopy. If you know that you won't use the copied data soon, you can instruct CPU to completely bypass the caches to avoid the pollution of caches.
Well, non-temporal copy would be interesting if you can figure out a way to get the appropriate buffers in operation in a Unix environment. But which is not, I don't think it's trivial to do, but I challenge you to do it. But I still don't think that that's the solution to removing atomics in code where there isn't actual sharing.
Well, just the problem, I don't really want to kill sharing at all. Definitely not. What I'm thinking about is just replacing those shallow copies where we are doing a lot of atomical operations to not copy 16 bytes. I mean, if you are appending small, very small buffer list, then it might be much more will be much more cheaper to do actually memcopy instead of playing with sharing.
My worry with that though is that there might be code that depends on this being sharing, and like buffer append would be reference semantics instead of value, if that makes sense. Like appending a
Oh,
buffer
okay,
pointer
that's
and
good
then
point.
changing it.
Yeah, I would be those types of places should be few and far between. And we should try to, like, if they depend on that, figure out a way to whatever, change the API so that these are different API that's like explicit about that. Like append
That's kind of what worried.
shallow or something.
Yeah.
Yeah.
It worries me that we've kind of like mangled all of this into like, we've got behavior that we might expect that, it's all implicit, right? Like,
Right. I mean, I
Who knows?
agree, but we're here now, so we have to.
This
Yeah.
seems
I know.
this seems weird. This seems weird to me, though. I mean, moving. I mean, if it. Well, I mean, feel free to micro benchmark and show you can make it faster one way with one sort of set of primitives or another. But this isn't a recipe for this isn't an idiom for avoiding atomic operations. This isn't.
Well, I would expect that it's pretty rare that we're appending very small buffers also, right? Like usually you're appending a char star with a length because you're doing it in code. But when you're doing 16 bytes, it's not because you have a 16-byte buffer pointer. There aren't that many of those.
The question
Typically.
is about the average size of our append. Of average size of buffer list, we are appending to another buffer list. It's possible to check.
Yeah. And maybe the other way around this is to find those handful of cases where we do have small buffer pointers that we're appending that are small that should be memcopied, and just change those to append, the pointer.cster, pointer.len to trigger a memcopy in those cases.
Yep.
Instead of changing the library. That might be safer.
Maybe an alternative is so the append takes the buffer pointer by reference. If we force it to pass by our value reference, then we could eliminate the reference counting there and also catch the places that might be doing something funny with reference semantics.
Yeah. That means all of those call sites would change to standard move on the buffer pointer, right?
Yep.
Right.
Okay.
And it's doable. It's entirely doable at compile time. We could deprecate just for one compilation. We could deprecate our variants of pushback or append, taking non-air value reference to buffer pointer.
Yeah, maybe before like investing a whole lot of time, I would maybe just do a survey and see how many cases of this there are.
Yep, let's invest.
Try to test that. Yeah.
Let's invest the time of the compiler. It's much cheaper.
Okay.
All right. Well, off to RGW stand up. Thanks, guys. Bye.
All right. See ya.
See you guys. See.
Do we have anything else we want to cover, or we beating the buffer horse?
Good for now.
Not sure if it's dead yet, but it's getting close.
I'm sure it will come up again.
Yep. All right. Sounds good.
Have a good one, guys.
Sure.
See ya.
See you later. Bye.
Bye.